Now the question number 7 is, a box with a square base and open top is to have a volume of 4 cubic decimeter. Find the dimensions of the box which will require the least material. Actually, in this problem, we have to make a box. You can say we have a metal sheet or a cardboard with which we have to make a box containing a volume 4 cubic decimeter, and material with which we have to make that box should be least. So actually, in this problem, the objective is to make the surface area of that particular box should be minimum. So this one is the box with dimensions as this one is the box with a square base. So its base is actually square. So length and width are equal. So we name it x, and that must be x, so that this base will become a square. And this one is the height of the box. Let this one is y. So the volume of this box is 4 cubic decimeter, and the material with which we have to make this box should be minimum. So we can say that using this side, and all other sides having surface area minimum. So let length of the box is equal to x, width of the box is equal to x, and height of the box is equal to y. These are assumptions. As given, volume is equal to 4 cubic decimeter, and the volume is actually length into width into height. So this will become x into y is equal to 4, and that will become x square y is equal to 4, and y is equal to 4 over x square. Name it to the equation number 1. And the surface area of the box, as we discussed earlier, that we have to make with least material. So that is actually surface area of the box, that should be minimum, and the surface area of the box actually is represented by S, which is x square plus xy plus xy plus xy and plus xy. This actually formed by, this one is actually area of the base, as the base is square, so that will become x into x. Area is actually length into width, so this one is the area of the base, that will become x square. This one is the area of one side, like this one. Obviously the dimensions involved in this side are x and y, so the area will become x into y. Similarly, the side opposite to that one is this one. The area of this side will also be xy, as this one is x and this one is y. And similarly, the backward side, this one is x, this one is y, so that will again become x into y. And the frontward side, which is this one, x into y. So these four sides are of area xy plus xy plus xy plus xy, and this one is the area of the base. As box is open, so we will not take the area of this one, because box is open. So the complete surface area of the box will become S is equal to x square plus 4xy. Now that should be actually minimum. Now we will take the help of our derivative theory. This s will become x square plus 4x, putting the value of y, which is 4 over x square from 1. So s is equal to x square plus 16 over x. This one is the function which we have to make minimum. Now differentiate this function. Let differentiate with respect to x. So ds over dx is equal to 2x, and the derivative of 1 over x is minus 1 over x square. So that will become minus 16 over x square. Again differentiating. So d2s by dx square is equal to, the derivative of 2x is 2, and the derivative of minus 1 over x square is plus 2 over x cube, because this can be written as 2x minus 16x raised to the power minus 2. Now we will take derivative of this function, that will become 2, and the derivative of 16x raised to the power minus 2 will become 32 over x cube. Now for stationary points, or the point at which the function which is represented here is surface area, that should be minimum. So we have to find our stationary points, and for this put first derivative is equal to 0. ds over dx is equal to 0. As ds over dx is 2x minus 16 over x square, 2x minus 16 over x square is equal to 0. By simplifying this one, taking an LCM, and we will get 2x cube minus 16 is equal to 0, and from here dividing by 2, x cube is equal to 8, and x is finally equal to 2. This one actually cubic equation, and will return 3 values actually, but the other 2 values will become a complex value. We have to make length or width. So this one is only a real number, which is x is equal to 2. Now put x is equal to 2 in our second derivative, so that we can conclude that either that surface area is maximum or minimum at that particular value, which is x is equal to 2. So by putting x is equal to 2, our second derivative is equal to 2 plus 32 over 2 cube, and which is 2 plus 4, and 4 plus 2 is actually 6. Here this one is actually 6, which is greater than 0. As second derivative is greater than 0, so the function which is actually surface area, that is minimum at stationary points, and the stationary point is x is equal to 2. So put x is equal to 2 in y is equal to 4 over x square, so that we can calculate the value of y, which is height in this particular case. So y is equal to 4 over 2 square, and y is equal to 1. Hence length of the box, which is represented by x, is 2. Width of the box, also represented by x, as our base was square. So length and width must be equal, and height of the box is equal to 1. So this one is actually the dimensions of the box, and you can verify that volume, which is x into y, so that will become 2 into 2 into 1, which is 4. So volume of our box, which is given and verified here, that is 4 cubic decimeter, but the material of making this box is minimum. Now question number 8. Find the dimensions of the rectangular garden having perimeter 80 meters if its area is to be maximum. Almost similar question previously discussed, that the perimeter is given of rectangular garden, but the area should be maximum. Solution: let the length of the rectangular garden is equal to x, width of the rectangular garden is equal to y. We have these are dimensions as the given value of parameter, which is 80 meter, and by formula perimeter is actually length of sum of length of all sides. So this will become actually x plus y plus y, which is 2 into x plus y, which is 80. And so this one is not 2 actually. X plus y is equal to, from here we can say x plus y is equal to 40. Dividing both sides by 2, and y will become 40 minus x. Now our objective is to get the maximum area, and the area formula of area is actually x into y. So that will become a is equal to x, and value of y is 40 minus x. So finally area is 40x minus x square. So this area must be maximum. So we have to take derivatives, first derivative, second derivative, and here is the first derivative, which is 40 minus 2x, and the second derivative is minus 2. And for stationary points, or the point at which the area must be maximum, put first derivative is equal to 0 and dA over dx is equal to 0, 40 minus 2x is equal to 0, and from here x is equal to 20, and put this x is equal to 20 in our second derivative, so that we can conclude that the area function either maximum or minimum. So when we put x is equal to 20 in second derivative, and the second derivative was only minus 2, a constant function which is less than 0, and as the second derivative is less than 0, so our function must be maximum at that particular point. So area is actually maximum at x is equal to 20, and put x is equal to 20 in equation 1, so that we can calculate the width of the rectangular garden, and y is equal to 40 minus x. So y will become 20, hence the dimensions of the box will become length of rectangular garden is equal to 20 and width of the rectangular garden is also 20. So we can say the dimensions of the rectangular garden are 20 meter and 20 meter.